On this episode of Peak, the lake that killed 2,000 people in just 12 hours. In nature, striking beauty is often a warning sign. Alluring blossoms and shiny berries invite you to pick your poison. Vivid creatures catch your eye, then leave you intoxicated. Idyllic mountain lakes draw you in and take your breath away, permanently. Such is the case with Lake Nyos, a lush locale in northwest Cameroon, situated on Africa's west coast. Just 30 miles from the Nigerian border, this area of Cameroon is a volcanic zone featuring a number of beautiful lake-filled craters. Among them is Nyos, a lake high in the mountains, filling the deep crater of an inactive volcano. A stream drains the lake to the northwest, plunging over a 130-foot waterfall. The scenic landscape, combined with its rich soil and safe drinking water, encouraged settlement. The area around the lake was well populated and included the villages of Nyos, Cha, Subum, Fang, Mashi, Munji, and Djingbe. Villagers tended to their lands and livestock, raised families, and went about their lives, unaware of a growing threat. In the early evening of Thursday, August 21st, 1986, heavy rains began to fall. They were typical for this time of year, the rainy season. By 9:30 p.m., the rain had stopped, and the night was calm and cool. Some villagers were already in their beds asleep. Others were enjoying meals, completing chores, or spending time with friends and family. Those who were still awake heard it, a series of rumbling sounds lasting no more than a minute. From his house on a cliff above the lake, Ephraim Che heard noises reminiscent of a rock slide. Looking down, he witnessed a white cloud rising from the lake. Many of those closest to the water came out of their homes to investigate the noise. Within seconds, they dropped to the ground, dead. The cloud, rising at 60 miles an hour, spread outward from the lake, sweeping over the crater's northern lip and into the lowlands toward the villages of Nyos, Cha, and Subum. Moving between 12 and 30 miles an hour, the cloud expanded for 16 miles. Within hours, 1,746 people were dead. Many of the victims died instantly, dropping to the ground in the middle of conversation or tasks. Some died in their sleep. The villagers' livestock and pets were also decimated, with 3,909 cattle, 3,342 fowl, 561 goats, and 364 sheep, all dead. Early the next morning, unaware of the disaster, Emmanuel Nju Mb, the chief of a regional health center, rode his bike from the village of Woom toward Nyos. Nearing the village of Cha, Emmanuel noticed a strange smell, became dizzy, and promptly fell unconscious. After a few hours, he awoke and continued on his way. As he rode, he came across a dead antelope, 2 dead rats, a dead dog, and other lifeless animals. He wondered if they'd been killed by a lightning strike. Reaching Nyos, he cycled toward a group of huts, eager to inquire about the dead animals. He stopped suddenly, horrified. Everyone in the huts was dead. More bodies lay where they fell outside. Emmanuel couldn't see or hear a single living soul. He threw down his bike and ran back to Woom, alerting authorities. By this time, survivors began to arrive in Woom and in Kambe, seeking medical care. They were scared, sick, and sore, having laid unconscious for several hours in the uncomfortable positions and locations they passed out in. The lucky ones had awoken after 6 hours. Others were unconscious for much longer, some up to 36 hours. It had been a regular night, they explained, until suddenly something had befallen them. Many reported smelling a strange odor, either rotten eggs or gunpowder. Their eyes burned. They began to gasp and choke and quickly fell unconscious. Others smelled no odor, but experienced fatigue, dizziness, and confusion, as well as a feeling of warmth before collapsing. Many people mentioned that their oil lamps and fires had gone out, despite having ample fuel. Government medical teams began treating and interviewing the survivors. Many had trauma from falls, including fractures and dislocations, as well as temporary paralysis and numbness from lying in a fixed position for several hours, sometimes days. Others had sores, mainly over bony prominences, and often on only one side of the body, due to lying in uncomfortable positions and on abrasive surfaces. Some people had burns from falling onto or near a heat source. One unfortunate patient, an elderly woman, had been cooking and passed out with her arm in the fire. It had to be amputated. Even days later, many survivors still suffered from respiratory issues, nausea, vomiting, and diarrhea. But most of all, they were devastated. Many of them had woken up to find their entire household, their whole family dead, along with all their neighbors and friends. Survivor Andrew Ewan, then just 13 years old, escaped the gas but lost 15 relatives. Speaking in 2001, he said, "It's printed on my mind. I remember it as the day when everything went wrong." Sule Amare, a cattle herder who survived when 99% of his village was wiped out, spoke of the rumbling sounds preceding the tragedy. "We thought that rain was coming. I went out and saw the moon shining. I wondered how rain could come without clouds." Within seconds, he lost consciousness. Halima Sule also heard the rumbling. "It sounded like the shouting of many voices," she said. A strange gust blew through her home, and she described falling unconscious, like a dead person. Survivor Joseph Enkawane described his experience. "I could not speak. I could not open my mouth because then I smelled something terrible. I heard my daughter snoring in a terrible way, very abnormal. When crossing to my daughter's bed, I collapsed and fell. I was there till 9 a.m, until a friend of mine came and knocked at my door. My arms had some wounds. I didn't really know how I got these wounds. I opened the door. I wanted to speak, but my breath would not come out. My daughter was already dead. I went to my daughter's bed thinking she was still sleeping. I slept till 4:30 p.m. on Friday. Then I managed to go over to my neighbors' houses. They were all dead. I decided to leave because my family was in Womb. I got my motorcycle. As I rode through Nyos, I didn't see any sign of any living thing." Survivor Margaret Wandia recalls breathing very hard and having no strength. She quickly passed out, and when she awoke, 3 of her 4 daughters were lying dead beside her. Ephraim Che, who had spotted the white cloud from his cliffside home the previous night, walked down to Nyos at first light. He was unsettled by the silence. The morning was usually alive with insect noises and bird song. He encountered his friend Halima Sule screaming and trying to rouse her father. The bodies of her 4 children and 31 other family members were scattered amid their compound of thatched huts. The family's 400 cows were dead in the field. Ephraim tried to look away. On that day, there were no flies on the dead. The flies were dead too. He ran down the hill sobbing and desperate to see his family. His parents, siblings, aunts, and uncles were all gone. It is August 21st, 1986, the end of the world, he believed. On the day of the disaster, 12-year-old Mercy Bai had traveled to Womb to buy supplies for her family of 26. While she was gone, all of her family members perished. She saved the money her family had given her for supplies, and despite her heartbreaking circumstances, later remarked that she was lucky to have something when some people were left with nothing. Over the next 2 days, after learning it was safe, people from neighboring villages traveled to affected areas to check on friends and family, help survivors recover, and bury the dead. Joining the recovery effort were 2 helicopter pilots from a Swiss missionary service. They reported their findings. The scale of death was profound, they noted, seeing countless people dead, as well as mammals, birds, amphibians, reptiles, and insects. Living insects were completely absent from the area for 48 hours after the event. Examining the human and animal remains, the pilots believed that death had come very quickly with minimal panic or pain. There was almost no evidence of agonal struggle, meaning that furniture and personal belongings were not in disarray due to movements of prolonged suffering. Victims who died in their beds were still tucked under their covers. Those that died outside showed only signs of collapse with no further movement or struggle. Animals and herds fell clustered together with no signs of panic, running, or dispersal. The pilots noticed lesions on the deceased, resembling those on survivors. Observers noted that the pattern of death was not uniform. In one goat pen, 4 of the goats died and 1 survived. In a home nearby, 5 family members died and 4 survived. Livestock was still happily grazing on high elevation areas, while animals in low-lying areas were wiped out. Plants in the area seemed unaffected, with the exception of vegetation on the south side of the lake, where a giant wave had swept the shore up to a height of 82 feet. Locals noticed that the water level of the lake had dropped by almost 3 feet. 2 days after the event, the president of Cameroon sent in personnel to resettle citizens, administer medical care, provide supplies, and bury the dead. Many of those sent in were fearful of the area and eager to leave. Sadly, the military began burying the dead in mass graves. Because of this, locals assert that the official fatality count reported by the government was too low and that the real number of deaths far exceeded 2,000. Seeking to better understand this frightening disaster with a death toll unprecedented in Cameroonian history, authorities invited researchers from around the world to investigate. In the coming days, American, British, Italian, French, German, Swiss, Japanese, and Israeli experts came to help. Villagers invited the international visitors to their homes and insisted on cooking for them. They had lost so much, but not their hospitality. On August 27, 1986, 6 days after the disaster, a 10-member research team landed in Cameroon. Dispatched by the United States Geological Survey, a scientific agency of the U.S. government, the team included a clinical physician, forensic pathologists, geologists, environmental engineers, water chemists, and a limnologist, a scientist who studies inland bodies of water. Arriving at Lake Nyos, they observed that the water was calm, but the usually blue lake had turned a rusty red color, and mats of vegetation bobbed on the surface. The area around the lake yielded interesting evidence. A massive fountain of water nearly 300 feet high had splashed over a high rock promontory on the lake's southwestern side, stripping away vegetation, and a large wave had surged up onto the southern shore. In addition, the steep west side of the lake showed evidence of a small but recent landslide. They could not ascertain whether it occurred before, during, or after the event. The team collected samples from local lakes, springs, and precipitation, and performed a range of tests. Like most lakes, Lake Nyos is stratified, having separate, distinct layers of water. Each layer has a different temperature, density, solute concentration, and type. Most lakes experience a mixing of layers, at least once per year, sometimes more, usually due to changing seasons. Lake Nyos, however, was discovered to be a rare type called a meromictic lake. The layers of meromictic lakes do not mix naturally and can remain unmixed for decades, even centuries. This can result in radically different conditions in each layer. In the hypolimnion, or bottom layer of Lake Nyos, the research team discovered that 1 liter of water contained 1 to 5 liters of dissolved gas, 98% of which was carbon dioxide. The remaining 2% was a mix of hydrogen, carbon monoxide, sulfur dioxide, and hydrogen sulfide. Only in the epilimnion, or top layer of the lake, did the team find measurable dissolved oxygen. The reddish-brown substance on the surface was ferric hydroxide, which we'll address later. Comparing surface water from before and after the event, the team noticed an increase in the concentration of most elements after the event. The concentration increased with depth, making it clear to the team that the bottom layer of the lake was much more concentrated than the top layer prior to the incident. Because the dissolved gas from the bottom layer contained so little sulfur and carbon monoxide and no hydrogen fluoride or chlorine compounds, scientists established that the gas was not the result of an injection of lava or volcanic gas into the lake. Temperature readings supported this, showing the lake bottom in a standard range, not heated by volcanic activity. However, the gas did come from below Lake Nyos, far, far below. Isotopic analysis of the gas confirmed that it was likely released from CO2-rich magma deep within the Earth, which cools as it ascends and loses its reactive components by the time it reaches the surface of the Earth, where it emerges through faults in the crust. From there, the CO2 either dissipates into the atmosphere or bubbles up in groundwater, as the research team found in local springs and stratified crater lakes like Nyos. Over time, the bottom layer of the lake becomes extremely saturated with CO2. Pressure and a lack of layer mixing keeps the CO2 trapped in a dissolved state at the lake bottom, until specific circumstances occur, often with deadly results. Experts still don't know exactly what triggered the release of the CO2 on that August evening in 1986, but it had to be a force that vertically moved water a critical distance, enough to cause supersaturated water from the bottom layer to mix with less dense upper layers, reducing pressure and releasing CO2 to effervesce out of the lake like popped champagne. An earthquake would have been sufficient, but was ruled out. The nearest recording station showed no seismic activity, and rock formations in high places around the lake hadn't budged an inch. The villagers' homes also showed no signs of quake damage or disarray. Some suggested a small volcanic eruption in the bottom of the lake. However, water samples showed only tiny traces of sulfur and carbon monoxide, and no hydrogen fluoride or chlorine. Also, depth sounding profiles mapping the lake floor showed no crater or disturbance that would indicate a vent. This also rules out the theory of a chamber of CO2 beneath the lake that vented. Others theorized that warmer or cooler rainwater falling in one region of the lake had triggered it. It has also been suggested that, once the water was 100% saturated with gas, infusions of additional gas could not remain in a dissolved state and began to form bubbles which triggered an eruption. While these are all sufficient triggers, a large number of experts believe the cause was a landslide into the lake, evidence of which was present on the steep western side. Whatever the cause, trapped CO2 was released from the lake in massive quantities. According to the team's calculations, at full saturation, Lake Nyos could hold 1.5 cubic kilometers of CO2. Amazingly, post-event testing showed that the bottom layer of the lake was still 30% saturated with CO2. This meant that if the lake had been fully saturated at the time of the event, the amount of CO2 released by Lake Nyos on August 21, 1986, was around 1 cubic kilometer of CO2. This figure was bolstered by calculations done regarding the lake level drop. In order to drop the lake level by almost 3 feet, the volume removed from the lake would be approximately 1 cubic kilometer. As the gas rose in the lake, it expanded and pushed up water overlying it. The displaced water and effervescing CO2 escaping from the lake produced the loud rumbling and bubbling sounds that survivors reported. Bursts of gas and columns of displaced water also generated waves on the surface. Hitching a ride with the rising gas was dissolved ferrous iron, brought in large quantities from the bottom of the lake to the surface. Once exposed to oxygen, the released ferrous iron became colloidal ferric iron, the reddish-brown substance on the lake's surface, observed by researchers and villagers. The escaped carbon dioxide, 1 cubic kilometer of it, kept rising until it was overcome by gravity. The pattern of dead animals above the crater rim indicated that the cloud rose over 300 feet above the lake. Because it was denser than the surrounding air, the CO2 cloud maintained its integrity. Displacing the ambient air, the cloud spread across the lake, then spilled over the rim of the crater and flowed into low-lying regions. Experts determined that the advancing cloud, now 150 feet tall and moving along the ground, formed a thick head along its front that contained its highest concentration of CO2, continuously recharged from its tail. This meant that the cloud remained lethal at greater distances. As the cloud flowed across obstacles in the environment such as hills, depressions, and vegetation, it slowed, stretched, and dispersed, turning enclosed spaces into pockets of high concentration that could linger for long periods of time. Some villagers were killed or rendered unconscious by the cloud as it swept over them. Others were killed or knocked out by entering an area still imbued with lingering CO2, like Emmanuel Nju Mb. Due to burial practices and limited resources, only 3 of the nearly 2,000 decedents had autopsies, and only one of those men had actually died from the event. The other 2 men died later in the hospital, one of pneumonia acquired prior to the event and one of an undisclosed condition. Forensic pathologists from the U.S. Geological Survey team ran tests and examined victims in the field and in hospitals. Analysis was performed on humans and animals, both living and dead. They concluded that the Lake Nyos victims suffered asphyxia from concentrated CO2 exposure. The carbon dioxide cloud had displaced the ambient air in the victims' environments, depriving them of essential oxygen. But even without oxygen displacement, the levels of CO2 were deadly. Air with 10% carbon dioxide induces hyperventilation, dizziness, and eventually coma. At 30% or more, like the air around Lake Nyos, a person simply takes a few breaths, then drops to the ground dead. Toxicology tests of the victims, living and dead, showed no hydrogen cyanide, carbon monoxide, or hydrogen sulfide. Because hydrogen sulfide has an odor of rotten eggs, and many survivors mentioned that smell, researchers thought they might find evidence of it, as well as sulfur gases that smell like gunpowder. They did not. Interestingly, the smells of rotten eggs and gunpowder are also frequently described by people exposed to high concentrations of CO2. It's a phenomenon called olfactory hallucination. These people also experience hallucinatory sensations of warmth during exposure, and afterwards commonly suffer from fatigue, nausea, and headaches, just as the Lake Nyos survivors reported. Experts monitoring the lake in the following months noticed that the CO2 saturation level was increasing again. The disaster had not interrupted the natural process of CO2-infused water entering the lake, probably from springs and groundwater. The disaster would occur again soon and keep recurring indefinitely unless something was done to stop it. Briefed about the lingering danger, the Cameroonian government ordered an evacuation and permanent resettlement of all citizens within an 18-mile radius of the lake. Many defied orders and returned to their homes near the lake. In response, the government destroyed the villages to prevent citizens from returning. The loss of life and subsequent abandonment of rich farming and grazing lands had a profound impact on the economic state of the region. Over 4,000 acres of land had to be abandoned, devastating staple crops such as maize, cassava, yams, peanuts, and soybeans. The price of cattle skyrocketed. As a result, citizens of the region suffered from starvation and poverty for some time afterward. Several nations provided financial aid, including Zaire, Gabon, Nigeria, the United States, Canada, Switzerland, and the Netherlands. Scientists were eager to implement a lasting solution at Lake Nyos. Experts vented the carbon dioxide manually for several years as financing was secured and equipment developed. Finally, in January of 2001, a permanent degassing pipe was installed. Funded by the U.S. Office of Foreign Disaster Assistance and installed by engineers from France's University of Savoie, the system consisted of a 6-inch diameter pipe fixed to a raft in the middle of the lake. The pipe extends to the deepest layer, over 660 feet deep, and siphons water from the bottom layers to the top, enabling carbon dioxide to escape from the lake continuously and in safe quantities. The degassing pipe worked well, but over time, experts concluded that a single pipe would not be enough. They determined that 5,500 tons of CO2 was flowing into the lake annually, and the single pipe was only delaying another disaster, not eliminating it. 2 additional degassing pipes were installed at the lake in 2011. Experts now know that the 1986 Lake Nyos event was an example of a rare natural disaster called a limnic eruption. Also called a lake overturn, a limnic eruption occurs when carbon dioxide dissolved in deep lake waters erupts suddenly out of the lake and forms a cloud of gas capable of asphyxiating and killing humans, pets, livestock, and wildlife. They may also cause dangerous waves and enormous spurts of water. Limnic eruptions can be triggered by volcanic events, earthquakes, landslides, and other sufficient activity. Lakes that experience this phenomenon are called limnically active or exploding lakes. As we saw with Lake Nyos, exploding lakes are stratified with no mixing activity, are fed with CO2-saturated water, and are located in areas with volcanic activity. Because the underlying causes are hard to identify, a thorough understanding of the phenomenon has been relatively recent in the scientific community. The phenomenon itself, however, has been around for tens of millions of years. Pit fossil deposits in Messel, Germany, indicate that a limnic eruption occurred there in the Eocene epoch. Casualties of the eruption are displayed in beautifully preserved fossils and include extinct herbivores, early primates, crocodiles, turtles, anteaters, birds, frogs, and insects. In 406 BC, according to Plutarch, Lake Albano, a volcanic crater lake near Rome, swelled despite a lack of rain or tributaries feeding the lake. It eventually spilled over into the surrounding hills and flooded vineyards, fields, and settlements. Modern-day experts suspect that the Lake Albano event was caused by a gradual buildup of gases trapped at the bottom of the lake that eventually released and produced waves of water that spilled out over the crater and flooded surrounding areas. After scientists determined the cause of the Lake Nyos disaster in 1986, they began testing other lakes in West Central Africa. The geological and environmental conditions of the region made it especially conducive to the phenomenon, and scientists were eager to prevent future tragedies. First, they zeroed in on Lake Monoun, a volcanic crater lake shaped like a bow, also in Cameroon. On August 15, 1984, 2 years before the Lake Nyos disaster, a limnic eruption occurred at Lake Monoun, 60 miles southeast of Lake Nyos. Witnesses reported a loud noise around 10:30 p.m. and a smoke-like cloud emanating from the eastern part of the lake that smelled acidic and bitter. Also on the eastern side, vegetation was flattened by a 16-foot wave. Between 3 a.m. and dawn, the gas cloud killed 37 people. They were all in vehicles or traveling on foot down a stretch of road running alongside the lake. Unbeknownst to travelers, a dip in the road had filled with deadly concentrated CO2, and they were heading straight to it. A truck carrying 12 people stalled, its engine deprived of oxygen. 10 individuals got out of the truck, then fell to the ground, dead. The 2 people sitting on top of the truck survived. Because carbon dioxide is heavier than air, it remains close to the ground. The 2 fortunate folks on top of the truck were high enough to avoid the CO2 pocket. For some time after, the cause of the tragedy was unknown. Some people accused the government of carrying out a chemical attack. Others suspected terrorism. Many pointed to local legends that warned of vengeful spirits in surrounding lakes who caused them to explode and drown entire villages. The U.S. Embassy in Yaoundé contacted volcanologist Haraldur Sigurdsson to investigate. After a thorough analysis, Sigurdsson concluded that the Lake Monoun disaster had been caused by a huge volume of magma-generated CO2 erupting from the lake and asphyxiating the victims. He referred to the event as a, quote, hitherto unknown natural hazard that had the potential to kill hundreds, even thousands of people. Sigurdsson briefed authorities and other specialists. He also submitted his findings to Science magazine, who rejected them, calling them far-fetched. This was in 1986, just a few months before the Lake Nyos tragedy. Degassing pipes and a solar-powered pump have been installed at Lake Monoun, but so far the natural CO2 intake of the lake is outpacing the pumps. Another pump will need to be installed to completely eliminate the threat. A third lake in West Central Africa is making experts extremely nervous. One of the African Great Lakes, Lake Kivu, is situated on the border between Rwanda and the Democratic Republic of the Congo. At 55 miles long and 30 miles wide, it's Africa's 8th largest lake and the world's 18th deepest. It lies in a rift valley that is being slowly pulled apart by tectonic forces, resulting in volcanic activity throughout the area. This activity has spawned a series of springs beneath Lake Kivu that infuses its bottom layers with water and carbon dioxide. Also present in huge quantities is methane gas, either introduced to the lake through the springs or produced by CO2-utilizing bacteria. Normally, these gases would bubble up and out of the lake, but Lake Kivu is extremely deep, more than 1,500 feet at its deepest. Under tremendous pressure from the weight of so much water, the carbon dioxide and methane remain dissolved. Salt from the springs adds to the density of the bottom layers. Kivu is also a meromictic lake, possessing layers that do not mix. Lake Kivu hasn't erupted for a long time, but that's not necessarily a good sign. When conditions of a lake remain the same, limnic eruptions are recurring events. Sediment cores taken from the bottom of the lake indicate that several eruptions have occurred in the last 5,000 years. Researchers noted gaps in the layers of plankton and algae fossils within the cores, suggesting that there may have been mass die-offs of organisms in the lake at different periods. The sediment record also shows at least one eruption caused by a drought that evaporated a huge amount of water from the lake and reduced pressure to such a degree that the dissolved gases in the bottom layer were released. This makes dry periods more nerve-wracking. Other possible triggers include earthquakes and nearby volcanic eruptions, which are common for the region. Bathymetric surveys revealed cone-like structures on the bottom of the lake that are likely volcanic in origin, raising the possibility that a volcanic eruption could occur on the bottom of the lake and then trigger a limnic eruption. The 2021 eruption of nearby Mount Nyiragongo did not cause a limnic eruption, but experts believe that lava flowed through underground fractures beneath the lake. One day after the volcano erupted, a sandbar by the lake collapsed, likely demolished by a tremor. Guests at a nearby hotel also reported that an area of offshore waters appeared to be boiling, possibly from a small release of gases there. Experts estimate that 65 cubic kilometers or 16 cubic miles of methane are present in the bottom of Lake Kivu. Also present is a huge amount of carbon dioxide, 256 cubic kilometers or 61 cubic miles. That's 256 times the amount of CO2 in the Lake Nyos gas cloud. If released, these gases would cause one of the most catastrophic natural disasters in human history. Given the lake's size, the massive volume of gas trapped in the lake, and the number of people living in its proximity, a limnic eruption would kill at least 2 million people. Not only would an enormous cloud of CO2 kill every living creature for miles, the explosion of gas and water on the surface of the lake would likely generate deadly tsunamis. The methane could also ignite, adding another level of horror. Water samples taken in 1974 and 2004 showed a 15 to 20% increase in methane and a 10% increase in CO2 in the lake over 30 years, indicating that the lake could reach full saturation in this century. As of 2021, the lake appears to be 50% saturated with methane and CO2. Scientists agree that Lake Kivu requires a permanent solution to degas the bottom layer and mitigate the risks. Others have been eager to tap the valuable methane reserves in the lake. 60 cubic kilometers of methane is equivalent to 10 times the annual energy needs of both Rwanda and the Democratic Republic of the Congo. In 2008, Rwanda began venting methane from the lake to burn as natural gas. The extraction technology was similar to the CO2 degassing pipes at Nyos and Monoun, but with the methane gas being captured for use rather than released. In 2015, a large methane extraction program came online, harvesting the gas and supplying electricity to local grids. Another methane facility became fully operational in 2021, and more are expected in the coming years. Experts say the gas could rake in over $40 billion in US dollars over the next 50 years. It's a boon for both developing nations, especially energy-starved Rwanda, where only 35% of people currently have access to electricity. Not only will these programs provide Rwanda and the DRC with the energy they need, they'll also be able to sell electricity to neighboring African nations. In addition to the economic benefits, the methane extraction efforts at Lake Kivu could also reduce the risk of a limnic eruption. But unfortunately, not fast enough. At the current speed of extraction, it will take 25 years to extract just 5% of the lake's methane, and barely making a dent in the massive volume of carbon dioxide still present. To reduce the risk of limnic eruption, the extraction of both gases would need to increase significantly in coming years. Even more so if fresh gases are being infused into the lake bottom, as the 1974 and 2004 testing showed. But experts have to be very careful not to affect the pressure differences in the lake's layers, which could have disastrous consequences, only one of which is a limnic eruption. They also have to be careful not to alter the ecosystems in the lake, which many people depend on. Progress is clearly being made at Lake Kivu, but the threat, it seems, is still very present. And speaking of looming threats, back in Cameroon, geologists discovered a new hazard putting the villagers of Lake Nyos at risk. Along one side of the lake, a natural dam composed of volcanic rock is crumbling. Worn down by erosion and weakened by landslides, the dam is now full of holes and large leaks. Researchers estimate that the dam will breach by 2025 if nothing is done. A breach would release 13.5 billion gallons of water from Lake Nyos and drown the villages below. The Cameroonian government is aware of the issue, but doubts it will breach anytime soon. In spite of the dangers they face, people have returned to Lake Nyos. Some are returning to their ancestral lands. Some are newcomers looking for a fertile place to raise crops and kids. In the regional language of Amen, the name Nyos means good. But in Itanyacom, a related dialect, Nyos means to crush. The coming years will tell us which name rings true. Let's hope good wins out.